Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC B12E2 indicates a low-level failure in the electric steering lock, specifically related to the MTRCUT1 signal. This code is crucial for ensuring the vehicle's steering system remains functional and secure. When the body control module detects this abnormality, it triggers the storage of the DTC to alert the technician of a potential issue. The components involved in this error include the electric steering lock, which controls the locking mechanism of the steering column to prevent unauthorized use, and the body control module, which processes signals and manages various functions in the vehicle's electrical system. The MTRCUT1 signal plays a vital role in communicating the status of the steering lock. Its failure could lead to issues with starting the vehicle or controlling steering functionality, making this an important code to troubleshoot promptly. The error description for DTC B12E highlights the critical components involved. The electric steering lock is integrated with the steering column and is designed to secure the steering mechanism when the vehicle is turned off, ensuring anti-theft functionality. The body control module, BCM, located in the cabin area, monitors and controls various electrical systems within the vehicle, including the steering lock. Specifically, MTRCUT1 and MTRCUT2 signals are essential for the BCM to verify the status of the steering lock. MTRCUT1 indicates if the steering lock is engaged, while MTRCUT2 relates to the ignition circuit. If the BCM detects an issue with either of these signals, it designates a low-level failure, necessitating immediate inspection and troubleshooting to restore normal function and vehicle security. When troubleshooting DTC B12E2, several possible causes must be considered. First, power supply issues may prevent the electric steering lock from functioning correctly. Inspecting fuses such as B22 and B29 is vital, as blown fuses can disrupt critical circuits. Next, open circuits in the MTRCUT1 or MTRCUT2 lines could lead to failure in signal transmission. Unbroken continuity is essential for the electric steering lock to receive the necessary information from the BCM. Additionally, short circuits can occur, leading to incorrect readings and malfunction. Lastly, faulty components like the electric steering lock or body control module must be evaluated, as their malfunction directly impacts the steering lock operation. All these factors contribute to the troubleshooting process, and each must be examined carefully. The symptoms associated with DTC B12E2 can provide critical insight during the troubleshooting process. One prominent symptom is a malfunction of the steering lock, which may either engage unexpectedly or fail to engage, preventing the vehicle from being started. This problem can lead to additional safety concerns and affect the usability of the vehicle. The activation of DTC B12E2 itself serves as an indication that the body control module has detected an abnormality. In some cases, drivers may also experience starting issues, as the vehicle may not recognize that the steering lock is disengaged when attempting to start the engine. Understanding these symptoms is crucial for diagnosing the problem accurately and ensuring an effective repair. The first troubleshooting step for addressing DTC B12E2 involves a confirmation procedure that requires cycling the vehicle through various modes. The technician needs to turn the vehicle to the off or lock position, then to accessory, followed by the on position, and back to off again, repeating this cycle 10 times. This procedure is highly relevant, as it may help reset the body control module's assessment of the system and provide a clearer indication of the gear status. Carefully performing this action can sometimes clear temporary faults and confirm whether the error persists. This simple yet effective first step is essential in understanding the health of the electric steering lock system before delving deeper into more complex inspections. After completing the initial confirmation procedure, the technician should inspect the relevant fuses, specifically fuses B22 and B29. Ensuring these fuses are intact is critical, as blown fuses can lead to loss of power or malfunction in the electric steering lock system. Following this, continuity inspection of the key circuits involved is essential. This includes checking the GND circuit, MTRCUT1 signal, and MTRCUT2 signal to ascertain that no breaks or faults exist. Use a multimeter to track resistance and verify that all readings are within the acceptable range. Performing these checks will help identify any electrical issues contributing to the DTC B12E2 code and guide the technician towards the next steps in resolving the problem. The next step in troubleshooting the DTC B12E2 involves focusing on the electric steering lock itself. Given that no direct testing method exists for this component, using a known good electric steering lock assembly is a practical approach. This method allows for direct comparison to determine whether the original electric steering lock is malfunctioning. By installing the good component and attempting to reproduce the failure, technicians can quickly identify if the electric steering lock is indeed the source of the problem. If the DTC and symptoms persist, additional inspection of related components may be needed. Conversely, if replacing the steering lock resolves the issue, it confirms that the original part was to blame, streamlining the repair process. The final troubleshooting step involves assessing the body control module, BCM, if prior inspections have indicated normal conditions for the electric steering lock and other components. The BCM plays a central role in managing various electronic systems within the vehicle, and if it is functioning improperly, it can lead to symptoms such as DTC B12E2. Detailed testing of the BCM is necessary, and if no issues are found in the steering lock or electrical connections, the BCM itself may be the faulty component. Repair or replacement of the BCM may be required to restore proper functionality. This step plays a pivotal role in accurately diagnosing the problem and ensuring that all electrical systems operate effectively in the Honda Accord. After completing the necessary repairs and replacements, a final verification step is crucial to confirm that the work carried out has resolved the issue associated with DTC B12E2. First, ensure that all electrical connections are securely reconnected, as loose or improper connections can reignite the problem. Next, clear the DTC from the system memory to reset the body control module. Following this, retest the vehicle to check if the DTC reappears. Observing normal operation during testing is essential, as it validates that the electric steering lock and associated components are functioning correctly. This comprehensive approach to final verification helps ensure the reliability of the repairs and the safety of the driver's steering system. To prevent issues related to DTC B12E2s from arising, implementing a strategic preventive maintenance routine is recommended. Regular inspection of fuses, especially B22 and B29, is crucial for monitoring electrical system integrity. This step should be incorporated into routine vehicle maintenance checks to catch potential problems early on. Additionally, consistently examining electrical connections throughout the steering and related systems can help ensure there are no loose or corroded wires that could lead to future failures. By performing these preventative checks, vehicle owners can avoid the inconveniences and safety risks associated with steering issues, thereby enhancing the longevity and reliability of their Honda Accord. In conclusion, understanding DTC B12E2 is essential for maintaining the safety and functionality of the Honda Accord's steering system. Proper diagnosis begins with recognizing the meaning and implications of the DTC, leading to a structured approach in troubleshooting and repairs. Each step, from confirming the issue to inspecting critical components, plays an integral role in accurately identifying the cause of the malfunction. By adhering to thorough procedures and performing final verification, technicians can ensure that repairs are effective and the vehicle remains safe to operate. Following a routine preventive maintenance strategy not only minimizes the risk of future issues, but also promotes greater peace of mind for drivers, emphasizing the importance of upkeep in maintaining the overall performance of the vehicle. Please like and subscribe to the channel. See you next time.